Hi, welcome. This is Mrs. Agapov. This is the second video for the team review prep for the second interim. This is page 2. We're going to dive into solve systems of two linear equations and check that off our to-do list. Alright, so like the first one, this video will go right into mainly the answers at first, which will take me about 4 to 5 minutes, and then I will jump into a more nitty-gritty of the standard and how I got my answers. So if you're just wanting to check your answers, stay tuned, and if you want a little bit more of an explanation, also wait until the end. I will be able to do that for you then. Alright, without further ado, let's get into it. Alright, the first one, you want to find the solution of the system of equations. So we're given x equals 5 and y equals 1/5 x minus 10. Alright, so I see an x here and I see an x here. I know what x equals, therefore this 5 can be replaced in here. So I have y equals 1/5 times 5 minus 10. Alright, multiply right across. 5 divided by 5, you're going to have 1. 1 minus 10, you end up with y equals -9. So down here you'll see that the original solution, or the solution for x, was 5 as it was given up here, meaning that our solution now for y is -9. Alright, moving on to 2b. This one, we're not given what x equals, but we are given what y equals here and what y equals here. So here we have y equals 4x plus 2 and y equals -5 minus 3. Alright, so I'm going to color code these. This one is going to be orange, and the other one is going to be a pretty blue. Pretty light blue. Alright. I know, but because both of them equal the same kind of variable, both of them equal y, I can set them equal to each other. So I'm going to do -x minus 3 equals 4x plus 2. 4x plus 2. Alright, now all I'm going to do is solve for x. And I'm going to do that by making 0 and making 1. So I'm going to move my -3 over to my 2. So I'm going to do the opposite of the sign. So +3 plus 3. And you end up with, this cancels out because it's 0. -x equals 4x plus 5. 4x plus 5. And do the little line thing to keep this organized for us all. There we go. Keep that line going. I want to get all my x's to one side. So I'm going to subtract 4x, subtract 4x. And I end up with, actually, -5. X equals 5. And now what times -5 will give me 5? That's going to be -1. So -1 equals x. Okay, that's just the first part of our solution. So down here, I'm going to write first part of our solution. So I'm going to write as my x value as -1. Now I got to plug this into one of my equations up here and solve for y. I'm going to do that with 4x plus 2. So I have y equals 4 times -1 plus 2. And all together, I'm going to end up with y equals -2. That's my solution here. And in the first video, you would have had me explain what that means by solutions there. I will dive into that a little bit more later in the video, but if you want to check that video out as well, I also explain it there. All right, checking out this very bottom one. Have x minus 2y equals 6, and then we have y equals negative 2x plus 2. All right, so unlike the other ones where, like the first one that we looked at, we had y equals, and then the other one we had x equals, and then y equals. This time we're only given what y equals, but I see there's a y here as well. So that means that I can put all of this into that y position. So I'm going to rewrite this. I'm going to do x minus 2 times this whole thing right here. So negative 2x plus 2 equals 6. Okay, and like with the second one, we're going to solve for x, and then we have to solve for y. So I'm going to distribute, solve that, and we end up with plus 4x minus 4 equals 6. Combine my like terms here, so I end up with 5x minus 6 equals, 5x minus 4 equals 6. That's what I meant to say. Move my 4 over, get my 5 alone, and we end up with x equals 2. All right, so that's part of my solution. We're not done yet. We have to go over here and find y. All right, so I'm just going to choose this one, this lovely equation here, because y is already solved for me. It's already by itself. So I'm going to do y equals negative 2 times 2, because that's what my x equaled here, plus 2. Okay, and then simplify and solve, and you end up with y equals negative 2. All right, so those are the solutions for these three problems, 2a, 2b, and 2c. If you want a deeper explanation of why this is, please stay tuned. If not, I will see you guys later. Have a good night. All right, we're jumping into this. All right. So for this particular standard, we want to understand the fundamental idea here is that variables can represent any number. So variables can represent, can't spell, there you go, Miss A. Okay, variables can represent any number. Okay, when we have the same variable in two different spots, but we know what that variable equals, or that number the variable equals, we can replace that value in for the exact same variable. So let's say that I had another equation. Instead of y equals 1/5 x minus 10, let's say that I had y equals 2/3 x plus 5. I can still substitute that 5 in for x and solve for my y. May not be very pretty, but you can do it. So y equals 2/3 times 5 plus 5. Simplify. There you go. So you get 10 over 3 plus 5. That's not going to look pretty, but you get the idea that regardless of what equation that is there, variables represent a number. They literally equal it. So the reason why mathematicians do this is because it's the only way that we can represent unknown things. But if this unknown thing is in multiple situations, multiple equations, then it must be consistent. We can't have x equals v and k. That doesn't make any sense. X has to be the same in every situation. X equals X. 5 equals 5. These are true statements. This is not. Not true. True. Yes, smiley face. We like this. We don't like this. So if we went over to this side, now I said it can represent any number. This doesn't look like it represents any number, but the moment that we plug in that -1 for the x, we get what y equals. So let's do that. We have y equals 4 times -1 plus 2. This whole thing, once we simplify, it'll equal one whole number. Y equals -4 plus 2. -4 plus 2 is going to give you a -2. There's our number. There's our variable that equals that number. So that means that if these two equations share the same solution, and what I mean by solution is by a coordinate point, x and y, then if I plug in this y value here, I will get this x value. Let's see if that works. Move this over. So we're going to do y equals -1 times a -1 minus 3. We're going to see y equals +1 minus 3. 1 minus 3 is going to get you y equals 1. There you go. So these two equations share the coordinate point -1, -1. Oh, no, sorry, -2, my bad. -1, 2. This is their shared coordinate point. So when mathematicians or any of your teachers literally say equal, it really means equal. Doesn't mean like kind of equal, sometimes equals. It literally means it equals each other. I know that seeing numbers as -x minus 3 equals 4x plus 2 doesn't look like a number. But as you can see, that when we actually simplify, when we actually know what these variables equal, we can find what this whole thing represents as a number. Okay, I hope that was clear. I know I rambled a little bit about that. I'm very passionate about math. So if anything that I said wasn't, you didn't quite understand it, please feel free to go to Miss Alexander at Morning Math. I know that she's more than willing to help anybody out. Go to BR, go to Miss Allen, any math teacher that you trust. And if you're like, hey, I really don't understand what solutions are or why I'm able to set two equations equal to each other, I'm sure that any math teacher here at Mercer is more than willing to help you out. You can always look at Khan Academy as well. All right, so the same thing is here. It kind of goes back to that idea that I was explaining, that this whole thing, once we know what x is, will equal a number. And that means that we can substitute it in for this other y. Remember, y equals y, x equals x, 5 equals 5. These are all true. So whenever we see the same variable just in a different spot, we can take whatever it equals and substitute it into that equation. That's why I was able to do this. And doing so allows me to find what x is. And then by doing that, finding that allows me to find y. So for this particular system of equations, these two different linear equations, their solution, their shared coordinate point is 2, -2. It's that point in which they're on the same graph. And if you looked at page 1 of this interim, you'd see that a solution is when two linear lines share the same coordinate point, when they're equal to each other. So that means that at this point right here, that point right here, it's not 2, -2, but it is a shared coordinate point, or the solution. It's an x and a y value of some kind or another. That's why we go through all this trouble to find the solution, is because we have to go through plugging things in and solving them. Another great way to check your work, let's say that you're not convinced that these two things are the coordinate point that you found, or maybe you think that you made a mistake. A good way to check your work, so check your work. You know, us math teachers are always happy when we see this on your page, an automatic 4, I swear it, would be to substitute in these values into both of these equations and see if they are equal on both sides. And maybe doing this will actually illustrate a little bit better what I mean when they share the same point. So let's look at this top one. Our shared coordinate point that we found was 2, -2. Let's see if it works. So I'm going to look at the top one. I'm going to use this pretty color. The first one was x minus 2y equals 6. And the second one was y equals -2x plus 2. All right, we got our x value, we have our y value. So I'm going to substitute all this into both of these equations. And what that's going to look like is that I'm going to put my 2 here, minus 2 times my y value. This is my x, this is my y, times that -2. I'm going to pop it in there. Equals 6. Let's see if this works. So I want to do this first. -2 times a -2 is going to be a positive 4. I was pausing to see if you guys could do it in your head first before I said it. 2 plus, let's keep the colors, positive 4 equals 6. Okay. And if we add 4 to 2, we get 6. Remember when I was saying that x equals x, 5 equals 5? This is a true statement. So far, this coordinate pair satisfies this is true for this equation. And what that means is that this line will hit, if we were to actually plot and put this line on a graph, that at some point, this line would have -2, 2. Let's see what that would look like. So -2, 2. Something like this. Say this is 2, -2. Okay. So for this line, we said it's orange, connects with the line here. Let's say it's that. Now I'm estimating, don't take my word for this exact line, but it looks something like this. All right, let's do the same thing here. We're checking our work, continuing on. We're getting that 4. So we have our y value here, which is -2. -2 equals -2 times 2. Oops, positive 2. Yep. Plus 2. Now let's see if this works out as well. I'm hoping it does, because that would be embarrassing. All right, -2 equals -2 times 2 is going to give me a -4. Plus 2. Woof! I was scared for a moment. I didn't think this was going to work, and it does! We have -2 equals -4 plus 2 positives is going to get me less negative, therefore moving closer to that 0, and we have -2 equals 2, which is a true statement, y'all. Love it. All right, so at the same time, that means that this line, and it has a negative slope. Boom. There we go. At this coordinate point, they are both equal. They share that point. All right, I think that's as far as I would like to go into the nitty-gritty of this standard. If there's anything that I said on here that's still a little confusing, you're more than welcome to come see me at lunch, before school, after school. You can also see Miss Alexander at the morning math table. I believe that she's handing out Mercer money for those students who go, along with BR and Alan. I know that they're more than happy to help anybody who comes knocking at their door. All right, thank you guys for joining me tonight. I hope this was beneficial for you. Have a great night. Thank you. Bye.